My name's Anton. This is actually my 5th time speaking at this conference, so I'm pretty thrilled, right? Lucas, he's my peer. We both work for AWS. We're both solution architects. I'm more on the serverless side of things like Lambda, event-driven architectures. Lucas more on the container side of things, Kubernetes, etc.
The fun side, right?
Yeah, the fun side, right, obviously. Right, and today we wanted to talk to you a little bit about applying generative AI to CVE remediation, right? So obviously there has to be a session about Gen AI, right? So how did we come up with this, right? So we're essentially engineers, right? With fancy titles like senior, principal, etc. But we're engineers, and all the stuff that the customers, the organizations that we work with do, it's kind of pretty close to us, right? We know the pain, right? So with this technology, we try to understand how we can actually remediate some of the real pain points that some of those organizations have. Now, a quick intro into what CVE is, right? Now, quick show of hands. How many of you are already aware of CVEs and deal? Okay, good. We're at the right conference. All right. So, there are a lot of those CVEs all the time, right? The total number of common vulnerabilities increases by 25% in this year, right, to almost 35,000 vulnerabilities, right? Almost 3,000 a month. That's a lot, right? That is a lot. If you look at, different problems associated with CVEs, right? Organizations with more than 100 staff see more high or critical risk vulnerabilities. So the more people you have, the more vulnerabilities you have. It takes about 60 days on average to resolve that vulnerability. That's a lot, right? Because it's not like, you know about that vulnerability. No, the evil people who are trying to hack you, they also know about that vulnerability, right? So they got on average 60 days to exploit it. But it's not just 60 days, right? 75 of attacks in 2020 use vulnerabilities that are at least 2 years old, right? So I'm curious, right? Let's see. How many of you think that it takes about a month to fix a CVE in your environments? 2 months? Up to 6 months? Okay, up to a year? Okay, so you know what we're talking about here, okay? Frequent scanning correlates to much faster remediation time. That's kind of given. Now, this in a nutshell is a process of addressing a vulnerability, okay? First, you need to identify it. Okay, then you need to analyze whether that vulnerability is even applicable to what you do. Then you need to do some risk assessment, right? So for example, a new vulnerability was detected in a particular Node.js or Java, yay, log4j, right? Are you even using that, right? Is this even applicable to you? And if you are using that, are you using it in a way that, that exposes you to this vulnerability? And obviously, remediation. And the fun part, this is a cycle. This is never stops. This is never going to stop, right? This is only going to become more and more and more labor intensive. Now, what me and Lucas didn't like in this cycle is that today, a lot of pieces of this cycle is very human dependent, right? It's still up to engineers, like people like us, right? To basically, okay, there's a list of new CVEs, or someone posted on LinkedIn, oh my God, I'm using that framework, right? And it's up to you to fix it. In many cases, there's no process, right? In many cases, when there is process, especially for larger organizations and regulated industry, that process is laborious, right? And this essentially takes your attention from delivering business value, right? Because, you need to fix that stuff all the time. So we were not a huge fans of the fact that, these steps are manual. What we wanted to achieve, right? How do we think of this? What would vulnerability management in future look like? So obviously, right, it's 2024, right? You have to stuff Gen AI somewhere. We want it to be Gen AI powered, and you will see today what exactly we mean when we're saying Gen AI powered, right? So essentially, what's the idea of Gen AI? Some of the, work that people do, right? Some of the laborious stuff that is not super exciting, how can we offload that to Gen AI? How can we use Gen AI instead? Automate it. That's like the key thing, right? Hundreds and thousands of those vulnerabilities, you want it to be automated as possible, but with some potential, human approval in the loop, right? Because, I don't know how much you trust GenAI at this point, if you heard about hallucinations, right? But probably you want to check, what's happening there before you push that stuff to production. Do not reinvent the wheel, right? The idea kind of that we set to ourselves is we don't want to reinvent the processes, right, to basically redefine how CI/CD and CVE patching works. We want to base the solution on existing principles, right? And the idea here is it will be easy to adopt that solution. Serverless and event-driven. Now, if we would have said, like, OK, we've built this solution, but in order to run the solution, you need a 15-node Kubernetes cluster spread across 3 regions, probably not the best solution. So we wanted that solution to be as lightweight as possible and event-driven. What does it mean to be event-driven? Well, you're not doing anything unless something happened. Only when something happened, only when new container image was pushed to container registry, this is where you do the analysis. You don't have any idle workloads running up there. And integrated experience, right? Basically, the solution needs to feel an integral part of what you already have, right? It doesn't need to feel like foreign. So we're from AWS, right? 2 services that we used for this was Amazon Inspector and Amazon Bedrock. If you're not familiar with those services, Amazon Inspector is a service that basically scans container images for vulnerabilities and provides you with a list of CVEs, right? There are many open source alternatives. There are many other tools like Docker Scout, and it's not something unique, right? It's just the AWS service that does that. Bedrock is our LLM, right? It's our GenAI service, right? It provides APIs. You make a query, ask it a question, tell me a story about Elsa. That's what I use it for mostly with my kids, right? It generates you text. There are many other GenAI services, generative AI services out there. But these are the 2 that we used. And going a little bit forward, right, yes, we also thought about how do we expand the ecosystem to services which are not directly AWS. So we use these 2 services to address this workflow. So we used Inspector for identify, analyze, and assessment, right? Because this is what kind of Inspector does, right? And we use Bedrock for remediation. Now, how exactly that workflow looked like? Generative AI-based vulnerability management. So it always starts with an application, right? You always have your applications that you're running in your environments. You have your developers who are having fun building those applications and writing those applications. Now, at some point in time, they need to do git push, right? The CI magic is happening, and that application is being containerized and put into some container registry, like ECR, right? Elastic Container Registry, right? Or Docker Hub, or whatever you use, right? Now, from that point in time, and this is standard. Up to this point, this is completely standard. From that point in time, we want to automatically, right, trigger vulnerability detection. And this is honestly also not new, right? It's been out forever, right? Tools like SonarQube, right? You have plenty of tools that you can use as part of your CI workflow. It's not CD yet, CI, right? To basically trigger some sort of security scanning, right? Once vulnerabilities are detected, this is where things start to be much more fun, right? So now we know the list of vulnerabilities. The tool, whatever security scanning tool we use, provided us a list of those vulnerabilities, right? But now we also know what we want to do with that. And our opinion was, OK, so we know those vulnerabilities. How can we actually take that knowledge and generate a PR from that knowledge that will address those vulnerabilities? OK? So in the prompt engineering, and we'll focus on this a little bit more, we're essentially going to generative AI and saying, hey, this is what a PR would look like, OK? These are the vulnerabilities that we've detected with the security tool. Can you generate a PR for us? Like literally a pull request, OK, a PR. So this is where generate pull request is happening. And then we also have some Python magic, basically a Python code that is completely open source on GitHub. We're literally opening a PR. So you will see the demo in about, 5 minutes, right? But essentially, the idea of the experience is you as a developer, you push your code just like you do every single day. And in a couple of minutes, you're getting a PR on that repo saying, we've detected these vulnerabilities, right? This is a PR to fix those vulnerabilities. And the only thing that you need to do is decide whether you want to click the merge button or you want to do some manual steps in addition, OK? Now, in context learning example, this is a pretty critical piece of what we do, right? Because, how many of you are using Gen AI in any way? Well, outside of generating Elsa stories, right? For work, right? How many of you are using Gen AI in, okay. Okay, how many of you are using Gen AI not for work, for generating Elsa stories? Okay, about 50-50, that's good. So if you're using various Gen AI services, you know that different LLM models, they come with different number of parameters, right? There are wide variety. It's kind of still a little bit of Wild West out there, right? What's important is some of them are more expensive than the others, right? Some models which are smarter, they would, it makes sense. They can be a little bit more expensive comparing to models that are not as configurable. Now, when would this model usually, not always, but usually be more expensive? Well, again, if that model is smarter, if it can generate you more stuff, maybe it can generate an Elsa story, but it can also generate a PR to fix Python application vulnerabilities, okay? Now, for our use case, we didn't really need a generic and super smart model. We needed something that was very specifically tuned for this use case. Okay, we had one use case. Maybe we'll expand it to a little bit more, right? But essentially, we wanted to help our model, right? And in this way, we don't have to use the most generic and biggest model out there. So we ended up with what?
Ended up with Llama 3.
Llama 13.
13
billion.
13 or 7.
Llama 3, 13 billion parameters, right? And the way we're helping that model, and you will see it in the demo, is we're not just supplying it with a list of detected vulnerabilities, we're also giving it a template of what that PR should look like. How did we get that template? Any ideas? Where is that template coming from?
One shot. Yeah. Another model.
Not really. Well, before Gen AI, we used to patch these things manually, right? So we have quite a lot of manual examples. So we took those manual examples and created a template out of it, right? There's no magic. Okay, Lucas, you want to take us through the architecture?
Sure, let me do it. Actually, let me go back one slide only. And I think one of the most important things when we are dealing with Gen AI is learn how to build a prompt. You could be super amazing on the amount of things that you can ask a model to do when you know how to build that prompt. And that will be basically for everything that we'll do from now in the future. How do you think Optimus from Tesla will move? He does in front, left, right, next, and he keeps thinking about that because he has his eyes as an input, for example. And this is exactly what we are doing. So we don't need to use a huge model because we are influencing the prompt that we are using to perform in a way that we're expecting it to perform. And this is true as well for RAG. How many of you know what RAG is? Retrieve Augmented Reality. Basically is...
Generation.
Sorry, speaking more than 2 languages at once is kind of hard sometimes. But what I'm saying is, RAG is nothing more than getting the data that you are trying to get using a vector thing hey, by the way, Facebook, search on that if there's anything related to Facebook. Grab that data and then build a prompt out of that to send to your model. So we are actually influencing the model response in a way that we want. So let me go now to demonstration, then it's gonna be more fun. I have a source code there, but before I start anything, what I'm gonna do is...
Wait, it's not showing.
It's not showing?
Yeah, I think you need to stop presentation.
Okay.
Yeah. Okay.
All right. So before I do anything, what I'm gonna do is I'm gonna log into my ECR repository and I'm gonna push image to that ECR repository. I'm gonna show you folks what that image looks like and what the application looks like. If the internet doesn't work, we can always have a video for play to you, but I think it's gonna work. So I'm gonna tag the image. It's pretty easy as of now, and then I'm gonna push that image to ECR. All right, so we should have the image here.
Want to show the code?
And yeah, for sure. And this is the application. So we have 2 repositories here. The first repository is my awesome application. And I use it in my awesome application. We use it to develop the prompt. So this is what Anton told us. So we look at the inspector CVEs generated by my awesome application. And based on that, we generated our prompt. The idea that we are building is the model doesn't need to know anything. The model just needs to know how to interpret the response. Inspector has the newest data about CVEs and everything. So this is pretty important. For that reason, we are using a really small model. So for this example, I'm going to use my amazing application. It's a Python application. How many of you are developers? All right, so I think this one should be pretty complex. I'm gonna open the code now. Don't freak off, please. Okay, so the application that we have now, it's a Python application. It's pretty complex, but what really matters of that application is the requirements that we are using, because we are gonna upgrade those requirements. We could upgrade any other thing. We could upgrade Docker images, we could upgrade code itself, because the template is what we are building. So we are gonna focus on the requirements for the demonstration itself. Okay, so we send a Docker image. Let me go back to the architecture. So we have the source code, as you know, and then we should trigger a continuous integration pipeline. What is the goal of a continuous integration pipeline? Generate an artifact. In this case, the artifact is the image hosted on ECR. If you are working on a front-end application, could be a zip file. If you are working in Java application, installing that as a process in your EC2 or VM, could be a jar file. So we have the ECR right here, and we are pushing that image. Of course, when we're working with container images, we work with tag promotion. So ideally, we won't build the image multiple times for different environments. We will work with tag and promote that image across environments. So we push that image. Once we push, inspector will be triggered, and it has identified that there is some CVEs. Now, inspector will classify the CVEs in 3 different categories. It will be critical, high, medium, and low CVE. So 4, I'm very bad at math. So I have a manual inspector, and then inspector, like any other piece that we have in AWS, it will generate events. So for anything that it does, it will generate events. So if you found a CVE, it will generate an event. And then with those events, we're gonna capture those in Event Bridge. We have 2 event types that we're taking in consideration. The first one is the finding event, and basically this is the CVE piece. So for every CVE inspector, it's gonna launch that event. It's gonna tell, hey, by the way, I have a CVE for that application. We're gonna capture that event, that's the CVE, and also inspector, if it knows what package needs to upgrade in order to remediate the library, it will also provide that information for us. So we are gonna grab that event, get the CVE, get the fixed in library, and then push that to Amazon DynamoDB using the ECR repository name as a partition key. Because the ECR repository name here as my primary key is the same name as my code commit. So usually people do that. They usually name the ECR repositories after the SCM repository. So this is exactly what we did here. All right, so here we have the data. We just have the data. We are not using Gen AI for anything. And what Anton and I were saying before, we need to build that prompt in a way that my model will understand what I'm asking it to do. So after the scan has completed on the ECR repository, inspector will generate another event for us, and that event we can capture and make Event Bridge call our application who is running on ECS. Now, this application is basically a container that will receive an input, and that input, it's basically the scan event complete with the repository name. It's up to the application to grab the CVE data, because the same partition key that we're using here is the same ECR repository name and the same repository name as well. So it's gonna grab that CVE data, it's gonna structure the model in the way that I'm expecting, it's gonna inject the in-context learning, and then send that to the model waiting for a completion. So I'm basically saying, here's an example of what I want for you to do. Now, this is the new data that I have, please act on top of that. So after we got that completion, I influence my model. I'm gonna show to you the prompt in a second, but I ask my model, I want you to generate a new version of my updated requirements.txt. I'm asking it for him, and it knows what versions needs to bump because of the CVEs that we injected, that we collected from the DynamoDB that came from the inspector. So we are updating only libraries in this use case, but we are expanding that, and we're gonna cover that later on in the presentation, to other different use cases. We can update requirements, we can do that with Docker files, we can do actually anything. If you have for example, a template in place that many people with your team follow, and they have a list of steps that they do, maybe you can use a module to accelerate that process a little bit. And then at the end, what is gonna happen is, of course, we need to clone the repository. So for the model input, other than the CVEs, I'm also inputting the requirements.txt. We could expand that to input the SBOOM files of the application as well. We are getting the list of CVEs from Dynamo. So we are passing the CVEs and the requirements.txt and all the configuration that we want, building the prompt, passing that to Bedrock, and then opening a PR and updating the requirements and having a really nice completion thing for us. So we have the image here.
You need to close the.
Oh, sorry. So we have the image here, that very complex application, and then once we open, you'll be able to see that it's still loading the image scan findings. Probably will take, should take 1 minute if everybody, yep, there you go. So good, at my side. We have critical, we have 3 critical, 100 high, 242 medium, low, and information. We can scroll down and we're gonna see the list of CVEs. There's a description as well, but in the event that we get, we can see much more information. So we can see something like this, libraries fixed at version X, Y, and Z. So we can act on top of that. After that, just to show you that I'm doing actually it live, this is my awesome application and the CVEs related to my awesome application that I use to build the prompt. If I refresh, and we hope that the Lambda has worked, there you go. So we should see another item in my DynamoDB table. That item is related to the ECR image that we pushed to the ECR repository. And then we have the list of vulnerabilities, those defined by inspectors. So inspectors send us that, we capture that with Lambda, and then we persisted that in a DynamoDB table. Now, we could filter also on Event Bridge. I'm capturing high, critical, and medium, but I could capture like only the critical CVEs if I wanted. So being and using those event services that AWS offers is pretty good. Now, once I have the DynamoDB with the CVEs, then I have a Lambda function that will trigger then the ECS service to then generate the pull request for us. And I'm gonna open this, the code in a second, but this is basically the log group for my Lambda function. Let me see if I have, there you go. So I think we have, this was generated today. And then we can go to the task logs. So my application is running an ECS Fargate container. And then that application is the application responsible to collect the CVE data and open the PR to the GitHub repo that you have. So let me check the logs. If we have it already. Actually, let me go to pull requests. And there's no pull request yet. So those things can happen in live code, as you can see here. Yep. For that reason, I have a video that I recorded yesterday. So important it is. If it happens live, it will be super nice. Okay, let me go to the video then, because at the end we can come back to see if it worked or not, but we can go to the video then. I'm not gonna stop that. Let me show to the point that I have. So. And then we can go back to that. So we have the image, we have the CVEs I was explaining. We have all that on Dynamo, and then we have the Lambda function here. The Lambda function is the function that we use to trigger the ECS service, and that was started. And then we can go now to the ECS service. This is the ECS cluster. And then we can open the task, and then we can open the logs of that task. And hopefully in the video, because I recorded yesterday, we're gonna see the logs related to the CVE happening and the PR being open. We can hope it to happen until the end of the presentation, but it's fine. So just to show you that we have no open pull requests. Once we refresh the page, there you go, we have some logs there. So we are cloning the My Amazing Application repo because we know the partition key and the repository name. So after clone, that what we are doing is we are getting the requirements.txt and we are getting the CVEs from the inspector. We are creating a branch called CVE branch and sending a request to the model. So all this information that I'm scrolling up here was generated by the model. So we created a branch called CVE finder, and then we delete the local directory. Now, if we refresh the page, we should see the CV Finder pull request open on that branch, the CV branch to the main. And this is what Anton talking about, the manual interaction. So for this particular use case, we are just upgrading the requirements.txt. And the way that I do behind the scenes, I basically use the regex based on this key to update my requirements.txt. But we could do anything that we want to do with the same architecture. I'm using for requirements.txt and Python, but we could have other application examples and everything. And what I told you is, those are the changes, and we are actually updating the library version. Now you could be thinking, this is exactly like the GitHub agent stuff that upgrades the library for us. But that's not the point here. The point is that we use this use case to do the updated of the requirements.txt. I could reuse the same use case with the same concepts with generative AI, RAG, and even in context learning to do other types of validations. And this is exactly what Anton is gonna cover for us right now, because we are improving that solution in partnership with NVIDIA to make something more. Let me just check again if the pull request is open or not. If not, I can come back later. But we are expanding that solution and doing that with NVIDIA. And then Anton's gonna cover that for us right now.
All right. Okay, cool. So thanks, Lucas. Now, I'm always excited when I see people taking pictures. It means this stuff is interesting. Everything you see here today will have QR codes at the very end. You can download everything.
And I promise you that works. I hope that it will work by the end of the session.
Right, but it's all in open source, right? This whole project is open source. It's on GitHub. There's a published blog explaining this whole thing. So there are a bunch of QR codes at the end that you can run it by yourself. Okay, so
this is what I just described, right?
Yeah.
We have Bedrock, we have Inspector, and then of course, like we are doing exactly the use case that we have for agents because we know how that use case works, but we are now expanding that piece with NVIDIA.
So we addressed what we initially defined as a baseline use case, okay? We want to detect vulnerabilities in the container image, right? Mostly in dependencies like requirements text, package JSON, Maven stuff, right? POM XML, if I recall correctly from my old Java days, right? And we want to create an automated way of remediating those CVEs, right? We got that. What would be the next step, right? Like, again, question for you. Anyone here has a process called AppSec team review in their organization? Anyone familiar with that, right? Anyone? Okay, we got a few hands. Okay, so essentially, yes, it's awesome to have CVE detected and remediated, but there is a next level to it, right? This is not where it ends, right? So for example, here in our initial solution, we were just checking dependencies mostly, right? How can we expand it beyond that, right? So let's say we detected a vulnerable dependency, okay? Yeah, it's a good idea to patch it, right? But what's the criticality of that finding, right? Do I need to patch it like literally right now, middle of the night, or okay, it can wait for Monday, okay? And the answer is probably, how is that vulnerability affecting my application right now? You know what, maybe I have 70 dependencies defined which I'm not even using, right? Pretty common, okay? So we wanted to go next level, right? We wanted to see not just scans for container images, but also how does that scan correlate with source code scan, right? So we detected vulnerabilities, but are those vulnerabilities actual vulnerabilities in the code that can actually be exploited, right? And we also wanted to see how can we have a system that kind of argues with itself, right? Trying to understand how critical that thing is and what needs to be done. So this is where we partnered with NVIDIA, right? And this is the extensibility of the system, right? Yeah, I'll click the button, okay. Right? This is the extensibility of the system. Like I said before, we're using Inspector and Bedrock, right? But we're trying to build a solution that can be extended with additional tools, right? That's the reason we put it in the open source. So if you're not familiar with this project, NVIDIA Morpheus, right? It's also open source, something that NVIDIA has on GitHub. Fun fact, literally right now, NVIDIA people are talking about this at a different conference in Virginia, if I recall correctly. Exactly about right? This. We're both local to Austin, but there's like literally today another conference with NVIDIA people talking about this. Okay, and essentially, they've taken the security analysis to a whole new level, right? Now, a few points about what Morpheus is. Essentially, it's an SDK, okay? It's an SDK, right? It's very cybersecurity focused. So you will see some details, but it analyzes more than just detect a CVE, right? It gets information from various sources, right? It scans your source code, it scans your SBOM files, and it tries to do usually what the application AppSec review team would do, right? But in an automated way, without let's open a ticket and wait for 3 weeks for someone on the AppSec team to pick it up, right? In a more automated way within few minutes, okay? Now, Lucas, you want to talk about this one?
Sure. So this one, I will talk at a very high level because I don't want to take us time on that one. But basically, the difference that we're going to use for the NVIDIA piece is that we are going to create a LangChain process where we have different models tailored to specific use cases. And those models will arc to each other. And if they don't know something, if they are not sure, the project will rather say, I'm not sure, than answer something that it's wrong. So for do that and don't hallucinate, we will need to do what? Inject an input to that model or to that combination of models, different inputs. So we will input the vector database itself for the CVEs that we can get, for example, using Inspector or using CVE Intel or using Docker Scout or any other tool. Then we're going to get the SBOM files because we need to see the list of libraries that we have available for that application. And we also can inject more stuff that NVIDIA also supports. But we're going to work with the SBOM files, the CVE, and of course the source code repository. After that, the project will generate a checklist of all the steps that it needs to follow. And then it's going to iterate on top of that checklist with different models, and each model owning its own piece of the architecture and of the stack. And at the end, we're going to send all that to a summarization model that will summarize based on the checklists and then provide an output for us. Now, with that output, me and Anton, we're going to augment that with Bedrock to act on top of that output. One of the things, requirements.txt. Another thing, the Docker file. For example, hey, you should use a user directly, not run your Docker file as root, for example. Just one thing that I can think about that. And then we're going to plug that in our solution, right?
Yep.
There you go.
Yeah, so the idea here is we want to reuse the architecture that we already built, right? But we want to add the NVIDIA piece in, right? Now, NVIDIA piece runs on EKS cluster, right, on Kubernetes cluster. So this is essentially the only change you see here. The right side, well, depends how you look at it, right? The left side, that side, right, is exactly the same. But in addition to PR opener that we had there, we're running that Morpheus agent. And it does exactly what Lucas said. It takes information from many sources, and Inspector is just one of these sources. It also actually scans the source code. It gets information from various repositories of vulnerabilities. And it tries to augment all of that to provide a much richer output that the PR opener can actually act on, right? That we can take and get to the Gen AI, right, to generate that PR and take an action on. Now, to show you some examples, yeah, this can barely seen, right? But yeah, this is internal log. Let's skip it, right? This part is interesting. I hope you can read it, right? And like I said, this is all, we'll get you links to all of that. But this is essentially a log that you're getting when that Morpheus agent is running, right? So I'm going to read it to you. Action, run the command. Action, input, conda list cryptography. Thought, I now know the final answer. Observation, run the command is not a valid tool. Try one of a list of tools. Final answer, the Docker container code contains several files operation that might be vulnerable to past traversal attacks, and so on, right? Essentially, this is like seeing really smart security people, right, arguing with each other, right, trying to come up with, the result of scanning of your code, right? This is probably one of my favorites, right? So this is a JSON object. This is just an example of the response. See the reason here. The CVE is not exploitable because the Docker container is not configured to use RSA key to be exploited, okay? So yes, we found a vulnerability, but it's not exploitable, right? So no need to wake up people 3 a.m. to fix that, right? Yep, there is something vulnerable in there, but you know what? Not a big deal. You can fix it next Monday, okay? So this model, it has a lot of benefits, right? What I really like about it, this model is not shy about saying, I don't know, right? Because sometimes I don't know is the answer, right? So, and like I said, open source, you can find it on GitHub. We'll have links at the end, okay? So this partnership, right, essentially allowed us to take the initial, AWS native solution that we've built and expand it with partner tools, right? And you saw the architecture. You want to insert SonarQube there? Go ahead. You want to inject another security tools that you have? Go ahead. It's not a product, right? We're solution architects, so we've built a solution and we put it on GitHub.
If you're going to reinvent and you want to learn how to talk to your EKS logs across the board and automate a lot of stuff, we're going to present about that as well in reinvent.
Yeah. We're going to show you here next year, right? When you go to prompt and saying, hey, my pod is failing, what's up with that? And it actually gives you a reason and what needs to be done.
And I think with this, you can have an idea of how we can build that.
Yeah. So let's start to summarize this, right? So what are the main points that we saw in this Gen AI-based vulnerability management, right? Obviously, scanning for vulnerabilities, right? That's the kind of bread and butter of it, right? The first thing is you need to understand whether that package, whether that source code repository even has vulnerabilities, right? Contextual learning, right? So yes, you can use the best model out there and ask it a very generic question, and maybe, especially with time, it can figure out how to properly answer that question exactly the way you want it. But that's going to be expensive. Okay, that might be expensive, right? What you can do is you can take a smaller model and actually help it, right, with some contextual information. And it worked amazingly well, right? Zero shot versus few shot prompting, right? It's kind of extension to that, right? So how much help you give to the model, right? And since, we both dealt with security vulnerability patching for for quite some time, we knew how to tweak the system, right? We knew how to engineer that prompt. Automated PR content generation. That was first time we saw the demo when we built it end to end. That was mind blowing, right? Imagine you push that 5-10 minutes later, depends, right? Larger containers, container images. Yeah, you want to try it? Okay, larger container images, right, take longer to scan, right? But essentially, a few minutes later, you see in a PR that says, okay, we fixed your vulnerabilities, right? So it's no longer manual effort. That was mind-blowing, right? And the cool part is, right, you're familiar with Git workflows. You click the merge button, right? That PR is merged, and the CI process starts again. So once you merge those fixes, your image will be rescanned again. And this continues until your image is at a phase where no vulnerability is detected. You can choose to ignore some vulnerabilities or to say, you know what, no, that might be breaking, okay? That's why we have the manual approval stage. Automated PR creation, that's the part that we really, really liked, right? You know the saying. If you do it more than twice, automate it. You want to go back to slides? Sure. Yeah. Okay. So in conclusion, we're just getting started, right? So we want to see how else Gen AI can be used in security area. I'm coming from about 7 years background of cloud security, right? And then I switched to the serverless, but once you're a security guy, you're always a security guy, right? So we're looking for interesting new ways we can use Gen AI in the security business. Because, this is a security conference. I'm guessing most people here are dealing with security. There's a lot of mundane tasks in security that can be automated, right? So security, cloud security, we want it to be about the wisdom that humans can bring and not, okay, now I need to go through this process that takes 2 hours and it's basically clicking these buttons and filling those forms, right? That's the part we want to automate, right? But we want to make sure that as humans, we're bringing wisdom to that process, not the mundane clicking. Proactive vulnerability management. Don't wait for, things to go south, right? If there are vulnerabilities, fix them. If you can fix them automatically as soon as possible, there's absolutely no reason not to do that. So be proactive. Holistic application safety. We started with a simple, let's just update dependencies thing, right? We need to start somewhere. But we're trying to expand that to additional scenarios. This is the partnership with NVIDIA we have, and essentially, how can we bring more security perspectives into the story of Gen AI vulnerability patching. And future-ready security posture. This is more of a marketing term, I would say, right, that I've added, right? But essentially, security is evolving, right? It has to evolve continuously. cloud security is probably one of the most competitive and fastly evolving areas of cloud, right? You got new companies all the time, you got new technologies all the time, because you have new vulnerabilities all the time. So the stuff that we're building, we want it to be future ready, right? And I think GenAI fits into that picture. So this is all we had. We can take a few questions, but if you want to learn more, all of this is public, right? Feel free to take a snapshot. Then you will need to take pictures of QR codes, right? Right. Yeah. Yeah, I see some hands. Give me a second, okay? All right. You want to go back to the slide?
Yeah, 1 second.
I just want to do the thank you slide, and then we can.
I just want to see if I... Yeah, no worries.
We'll blame the internet.
Yeah. You can test it in with yourself at your home. We have the GitHub repo, and it's working. I tested yesterday. Swear to you, folks.
Okay, so this is what we have. Okay, I hope you enjoyed it. I hope you found it useful. We got about, 15 minutes left. So if you have any questions, we'll be more than happy to. Yeah.
So I'm mostly talking about the risk assessment part in the Morpheus proposed architecture. I would assume that each one of those agents has some form of like an initial prompt or system prompt or something like that.
That's right.
Can you define the flow of the debate that is happening within? Because it seems that it has this chain of thought individually. Can you define the agent, like a department head, a security guy, a drunk guy that just took his shirt off? Like, can you define when they interact with each other and define the risk from each agent?
You can structure the pipeline in a way that you want, in like the pattern that you want to define. So for example, you want to use first the lemma 2 to validate this portion of the checklist of the pipeline based on your company use cases, you can do that. And then you can put some guardrails and everything, but ultimately what Morpheus is doing is just generating an output, right? So it's up to us to get that output and act on top of that. So we're gonna have a lot of work as developers still, but those mundane tasks that we can do faster with the model is what we're trying to do. We are gonna launch, and I think like, we are gonna launch the Morpheus blueprint with NVIDIA next month, where you can deploy the Morpheus stack easily. And we probably are gonna, I don't know if we're gonna publish a blog about that this year or next year. We're gonna talk about that sooner, like in great details, but
yeah,
you would be able to change the pipeline order and the justification, the validation, yeah.
And just one quick follow-up on that, can Bedrock do the same thing?
I mean, you can use Morpheus with Bedrock.
Yeah.
Okay.
Right, so you can use Morpheus and, for example, using Bedrock or OpenAI model or a NIN microservice that you have deployed on your EKS cluster, expose it as a load balancer, for example.
So Bedrock and Morpheus, they're not competing, they're complementing each other. Okay. Now, regarding Morpheus, if you remember me saying Morpheus is an SDK, it's very modular and composable, right? So you can define workflow. I don't know if you can get as deep as the drunk guy, right? But it's quite modular, right? And Bedrock, it's it's a set of APIs that you use to consume GenAI models, right? So the output of Morpheus becomes the input for Bedrock, right? They work side by side. Okay, yeah.
I heard you here. You said that you could accept or ignore a risk, right, that you've identified. And I know that it goes back into it to get rescanned again. But what if you've accepted a risk or a false positive, and then for some reason, something, like you said, environment changes, right? Now it's in the catalog and maybe the scoring and the way that that's calculated, but you've already accepted it.
That's a good question. That's a really good question. So I'll answer that by saying again, this is a solution. This is not a product, right? As any innovative solution, the way we're thinking about it, right, the ones who needed this kind of solution ASAP would probably adopt it in a solution form. But I do see that in future, some companies that actually deal with cloud security, they will have something similar in a product form, right? So today, if you adopt it as a solution, probably you need to have something of your own logic, right, to take care of those scenarios, right? It's extensible. It's literally a collection of resources in Python code, right, with some nice architecture diagrams on GitHub. But I do see that in future, this would be, a workflow like that can be provided actually as a product that supports those scenarios natively.
And then when you're you're developing your scoring. Are you using CVSS 3.1, the new 4.0, and then how are you? I know that you're collecting the data and then you're building your vector. How are you calculating that risk? Are you using the actual map from CVSS, or how does it calculate?
So for the CVEs, we validate the piece that calculates if a CVE is valid or not is inspector. So we got critical, high, and low. So we're using that, and that's it for calculate for my piece. Now for Morpheus one, the expanded version, they are integrating Morpheus with external and third-party APIs. So we have, for example, OAuth security injecting stuff on that. So, but I have not a lot of context around how they are doing that validation because we are not actually involved on developing the Morpheus itself. And we're gonna have more ideas around like October 3rd, I hope.
Yeah.